Hello everybody, I am David Shipley Alexander. Welcome to my Infinite Energy series on YouTube. This is my number 7 video and I've given it this title: Why is infinite energy infinite? But you notice I put quote marks around the word infinite. It's not really infinite, but it is so huge, and I wish to convey that and why that's important. So the answer to this question goes back to the foundation of what's called quantum mechanics, back about 1900. And the physics people then found out that to calculate the energy in light waves, they had to use this equation that energy equals the h, which is Planck's constant, and the other symbol is the Greek letter nu, which they use for the frequency of light. And as the principles of quantum mechanics were developed, they found that quantum mechanics not only allows but requires that energy is constantly coming out of a physical vacuum and going back in. And the equation is that the amount of energy that comes out times the amount of time it makes an appearance has to be less than that, the Planck's constant, the h. Now, the name of this energy, this particular form of energy, is called zero-point energy. That name comes from the fact that this energy exists even at absolute zero. It's not like the thermal energy that we know about with matter, where when the matter gets that cold, the thermal energy is gone. It's not like that. The energy can be thought of as a great number of electromagnetic waves, all different frequencies and orientations. And they have effects that are physical at different size ranges. If our size range is 1 micron, which is a 25th of 1/1000th of an inch, then if you have two metal plates that are highly polished and they're placed 1 micron apart, there's an extra force pushing those plates together called the Casimir force. This has been accurately measured and it agrees with the theoretical prediction. It's caused because the zero-point energy between the plates, these electromagnetic waves, are partly shorted out, and then outside the plates they're present, so the net result is that the plates are pushed together. At the size range of atoms, the physical effect is shown, for example, with liquid helium. Liquid helium at 1 atmosphere pressure, and it's already near absolute zero, will not freeze into solid helium unless a lot more pressure is applied to it. And the reason is that the zero-point energy is constantly bombarding the helium atoms and keeps them from aligning into a crystal shape. So let's take this size analysis down all the way that it makes sense. And that length is called the Planck length. It's about 10 to the minus 35 power meters. Incredibly small, 20 orders of magnitude smaller than the nuclei of atoms. And that length can be calculated, and then the amount of zero-point energy as mass in a sphere whose diameter is that length, that can be calculated. And these calculations are beneath. They are a reference here. And I wouldn't drag anybody through those calculations, but I went through them to get the feel for it. And that's where these numbers come from. And then I used the Einstein's equation for converting mass into energy, E equals mass times the speed of light squared. And then what happens is you get a calculation of the amount of energy in that small, they call it the Planck volume. And it's just an incomprehensibly big number. 10 to the exponent 108, and that's on a basis of a cubic centimeter. Cubic centimeter is like the size of our fingertip. So every cubic centimeter in the universe has that much energy in it. Really hard to comprehend that. But you notice, you write a number as an exponent, it's very compact. Doesn't give you the emotional feel of how big that number is. So in the way that 10 is 1 followed by 0, and 10 squared is 1 followed by 2 zeros. If you take 10 to the 108 power, it's a 1 followed by 108 zeros. It looks like this. So then you begin to get the idea of what a big number is, what this number is. Now the energy unit is a joule, that's a standard unit, which is a 1 watt times 1 second is a joule. That's a lot of joules. I think I counted them right, 108 zeros. Now, I understand that there are those that say, yes, but the energy is random, so you can't access it and you can't do much with it. I disagree with that. I have been studying advanced energy devices for 40 years, and I've seen some that are real, and they will be in future videos. My belief is that the devices at work, where they have energy coming out greater than the known energy inputs, are aligning or cohering a small amount of that amount of energy. You only need to align a little bit, and then you've got a lot that you didn't have before. So I believe that's what's happening. So that's what the size of the energy is and why it's important. And I'll be having more about that in future videos. Please leave your comments and questions below. I would like a thumbs up. And if you subscribe, then YouTube will send you a simple email when I put up my next video to let you know that. So thank you very much for your attention. And out of a wide range of possibilities, what will be the topic of my next video in the realm of advanced energy and propulsion? Stay tuned. So until then, I am David Shipley Alexander.